Today we're going to tackle about the three-dimensional distance formula. Now let's try this. Let's first derive the equation, the formula that we're looking for. So we have here a point and another point over here. So let's call this P and the other one is just P, another P. Yeah, I'm not going to put P sub 1, P sub 2, just that. Now we can draw a rectangle here, right? We can move it from here, and okay, let's make it exact on the P of the roof. Okay, here. Oop, it doesn't look like. Let me just delete it. So we have a point over here. And now let's just complete the cube. So we can derive our equation. I mean our formula. I do love calling it formulas equation. It's much better. But they are the same though. Okay. So let's perfect our square here. I mean our rectangle. Okay, now. So what we're going to find is the distance over in this region. So we can have a right triangle here. Let's make this a color red. And then let's make this line. So as we can see, we have a triangle here. And we have two triangles. We can make up a true triangle. So this is just a right triangle too. And this distance, what we're looking for, let's call this D. Okay. Now, let's name some. So let's name this as a change in Z. The change in Z direction. Here, let's call this the change in Z. And this one, let's call this is the change in X. And the height is going to be the change in Y. Here. Okay, that looks like Z, but let's just consider it as change in Y. Okay. Now we can use the Pythagorean theorem on the first triangle. So we have this right triangle, right? We have D here, and we've changed in Y. Let's call the thing here. Let's call this E. Okay, that's okay. Okay, now let's use the Pythagorean theorem. So the Pythagorean theorem is just D squared plus no. Let's put it here. D squared is equals to change in Y raised to the second power plus E raised to the second power. And now let's think the other right triangle here. So we got E as our hypotenuse and change in X and change in Y as our two sides. So E squared is going to be change in X, change in Z squared plus change in X squared. Okay, now what we can do is just substitute the E squared into the other equation. So now what we will have is, let's arrange this into change in X squared plus the change in Y squared plus the change in Z squared. So now to solve for the distance or D, let's take the square root of both sides. So let me just delete this and rewrite it better. So we got this. So as our final equation, we will get this thing. Now let's try this example problem. From point 1.4, 2 and point sub 2, which is 1, 2 and negative 5, find its distance. So first, let's just plot it. So looks like our point sub 1 is going to be here. Now let's look for the other point. So we want this, and we have a height of 5. So it is around here. Is it? We have a height of 2. Okay, so this is the distance between them. Okay. Just call this P sub 2. And we're going to delete the blue and red line so we can see it. Here, okay. So let me just delete this. So here, so they are like floating in space. Okay. So let's make a dot. So what we're trying to find is their distance, like in this region here. So what is D? So as we all know, our three-dimensional distance formula is going to be the D is equals to the square root of the change in X and squared plus the change in Y squared plus the change in Z squared. Now we can just plug in all of them. So the change in X, let's call this 1 comma negative 1 negative 4 squared plus 2 comma 2 negative 5 squared. Why do I keep saying comma? And negative 5 minus 2 squared. It's our Z. So I didn't. Okay, so we got negative 3 squared plus negative 3 squared again plus negative 7 squared. Now, what we can do is take the squared, so we get 9 plus 9 plus 49. Okay, so adding this, we got 67. So we have root 67 as our distance. And that's pretty much it for this problem. I hope you learned something, and goodbye.